Today, we're exploring a really powerful system that's all about perfecting the art of the argument. It's called Tennant's core logic, and it's a fascinating deep dive into what makes reasoning truly solid.
So, let's just start with a fundamental question. What does it take to build a truly airtight argument? I mean, an argument where every single step is not just correct, but absolutely essential. No fluff, no wasted words, no detours. How do you do that?
Well, to even begin to answer that, we have to look at our standard toolkit for reasoning, which is classical logic. It's the system most of us know, but it's not perfect. It has some flaws.
Look, classical logic is incredibly powerful. There's no question about that. But it has this weird quirk. It lets you use redundant or sometimes completely irrelevant information to get to your conclusion. Think of it like a recipe that tells you to add an ingredient you never actually use. Yeah, the dish turns out fine, but the recipe itself isn't as clean or efficient as it could be. And that's the exact problem that the philosopher Neil Tennant wanted to solve.
So, how do you fix that messy recipe? Well, that's where core logic comes in. It's a system that's been specifically designed to capture the absolute essence of valid reasoning. It's a leaner, meaner, and way more precise way of thinking.
Tennant's big idea was to build a system that really reflects how we should reason. The whole goal was to make sure that every single premise is meaningfully, directly connected to the conclusion. Imagine a logical chain where every single link is essential. If you take one out, the whole thing falls apart. No wasted steps, no irrelevant asides, just pure logic.
And he did this with two major reforms to classical logic. You could think of them as two big steps. The first one is called constructivization, which is all about building proofs in a clear step-by-step way. But the second one, relevantization, that's the real key. It's the step that makes sure every single one of those pieces is directly relevant to the final answer.
And here's what you get when you put those two ideas together. It's called a relevant intuitionistic reasoning system. I know it's a bit of a mouthful, but the idea behind it is actually pretty simple. It's a system where every single piece of the puzzle not only fits, but is absolutely necessary to create the final picture.
So, how does this thing actually work under the hood? Let's get into the engine room of core logic for a second and see how it completely rethinks the fundamental rules of making a proof. This is where the theory really gets put into practice.
The whole philosophy here is to strip away anything that isn't absolutely necessary. The goal is to have what are called irredundant rules. That just means every move you make in your argument, every rule of inference you use, has to be essential. And this isn't just about being neat and tidy. It actually leads to arguments that are fundamentally stronger.
Now this is where it gets really cool. You can see here how the old rules compare to core logic's streamlined approach. It keeps a basic starting point, reflexivity, but in a very minimal form. But check out the other two. The cut rule, which is used to chain proofs together, is shown to be totally redundant, you just don't need it. And thinning, this is the rule that lets you throw in irrelevant facts, is just eliminated completely. For instance, thinning is what would let you argue the sky is blue, therefore either Socrates is mortal or unicorns exist. Core logic just says nope and gets rid of that kind of nonsense. This is the real heart of the reform.
So, what's the big payoff for making all these changes? Well, the benefits are huge. Proofs aren't just cleaner, they are fundamentally stronger. You're guaranteed that everything is relevant. And maybe best of all, this isn't some totally alien system. You can take any proof from classical logic and convert it into a core proof, basically stripping out all the junk and revealing the pure, essential argument that was hiding inside.
Okay, so we've got this incredibly powerful, refined system. Let's take a look at where it's actually used, and also touch on a pretty interesting challenge it ran into. Because, of course, this stuff has to work in the real world.
And yeah, it turns out core logic isn't just some abstract idea, it's robust enough to provide a solid foundation for reasoning in the natural sciences. It works perfectly for a branch of math called intuitionistic mathematics. And in computer science, its clean structure is fantastic for creating more efficient algorithms that search for proofs.
But, in this whole quest for logical perfection, a fascinating little quirk popped up. It turns out that even this highly tuned system isn't completely flawless. It's known as the core logic paradox. And in simple terms, a logical paradox was actually found inside the system itself, a situation where its own super strict rules could be used to create a contradiction. Now, there have been technical fixes proposed, but it's just this powerful reminder that trying to create a completely perfect system of logic is a continuous process of refinement and improvement.
So the big takeaway here is that Tennant's core logic is a massive leap forward in our search for perfect reasoning. It gives us a framework for making arguments that are stronger, cleaner, and way more relevant. But it also leaves us with this final, really thought-provoking question. In a world with infinite complexity, can we ever design a system of logic that is truly 100% perfect?